All right, review for the quiz for 2C. So you have Flint, and they're want to know whether they should switch over to bottled water. A mean lead level, again, mean average, 15 parts per billion, is considered safe. Anything above 15 ppb is dangerous. A science teacher from Flint, Mr. Wilcox, believes the Flint water is unsafe. So he takes a random sample, that's important, 200 households. He finds the average lead level is 16.5 with a standard deviation of 8 ppb. All right, so step 1. Our mu is the true mean lead level of Flint water. Our average, 16.5. N is 200. And our alpha is 0.05 because it was not stated. Our ho and our ha. Mu is equal to 15. And he thinks it's unsafe, which he is thinking that it's above 15 ppb, so therefore greater than. This one's a little bit more vague, but you got to think about what it means. Step 3. Random was given. It does not say it's normally distributed, but 200 is greater than or equal to 30, so we're good to go. Now we calculate our t-value. We take our x bar from right here, minus our mu, divided by standard deviation, divided by the square root of 200. Remember, when we do this, alpha y equals, just have a fraction. Then you can either do it in your head or type in 16.5 minus 15, or just do 1.5. Then come down here and do 8 divided by square root of 200. And you see 2.65. Whoops. Little typo there. This should not be here. It should just be 2.65. With degrees of freedom of 199. Remember, we can use 199 because we're using the calculator. All right? Number 5, we draw our distribution. 2.65 is going to be, so 1, 2, it's going to be right here. And we're going to shade right. All right? Now, our P, which we get right here, but we're going to put in the calculator. So we're going to do our second vars and go to number 6 for TCDF. And we're going to put in 2.65 for our lower, 999 for our higher, upper, and 199 for our degrees of freedom. And there it is, 0.0043. And then our last statement, since my p-value is less than alpha, we reject the ho. We have convincing evidence that the true lead level is greater than 15 ppb. Hit pause if you need to. On to the next one. Okay, the makers of aspirin want to make sure their tablets contain the right amount of an active ingredient, acetylsalicylic acid. So they inspect a random sample of 30 tablets from a batch in production. When the production process is working properly, aspirin tablets have an average of 320 of the active ingredient. The amount of active ingredient in 30 selected tablets has a mean of 319 and a standard deviation of 3 milligrams. Here we're just testing at 0.05%, it gives us our ho and our ha. So it's actually done for you. Step 2 is done for you. All right? So 1, mu is the true mean amount of active ingredient in aspirin. Our X bar, mean, is 319. N is 30. And there's our significance level. It was given to us. Along with our ho and our ha was given to us. Now remember, whenever we see this, that's something special for step 5. All right? Remember that we're going to have to double in step 5 because not equals has left and right side. Step 3, random was given. And it did not say it was normally distributed, but 30 is greater than or equal to itself, so we're good to go. Step 4, do the calculation. So X bar minus mu, standard deviation, number. And our degrees of freedom is 29. That gives us negative 1.83. So when we draw, remember, it's actually going to be on both sides. At negative 1.83 and positive 1.83. The p-value is right there, but again, we're going to do our TCDF. So we do second vars, 6. I didn't hit second vars correctly, did I? Nope. Second vars, 6. Now, we're going to the left because we have a negative. We're going to do both sides, but we put negative 999. Okay, let's try that again. Negative 999. Then we put on our negative 1.83. And our degrees of freedom is 29. And look at that. Where'd that come from? 0.0388. 0.0388. 0.0388. So why does it say P is 0.782? Well, remember, we have to multiply by 2. And there we go. 0.78. Well, this is a little bit different. 0.775. Okay, I figured out why. This calculation is based on using this t-value instead of the rounded value right here. So if you use this t-value, you can see I put it right here and then doubled it, and there's where you get the 0.782. So either way is fine. I would accept, since we've been rounding pretty much, I would accept the previous answer of, 0.776 or 0.775. Either way, it's going to be greater than our alpha. So we failed to reject the ho. We do not have convincing evidence that the true mean is not equal to 320. Moving on. Last one. So during the regular season, the MSU men's basketball team scored an average of 80 points. Do you think they will be able to continue this average through the March Madness tournament? 6 games if they win. Mr. Spezio predicts that they will score less than their average since they will face stronger opponents in the regular season. In order to predict how they will score in the tournament, below is a random sample of 6 games from this season in which they play a top 25 team. So here are the 6 scores. 1, 2, 3, 4, 5, 6. Okay? It says the sample has a mean of 73.167. You didn't even have to put this in the calculator and find it. Standard deviation is given to you also. Here is the test level, 0.05. So 1, mu is the true mean points for MSU basketball. Our average was given to us. Our n, right here. And there's our alpha. On number 2, our ho is mu is 80. Okay, that's right here. But Mr. Spezio thinks it's going to be less, so he predicts mu is less than 80. Number 3, checking conditions. Okay, random was given. We were not told normal, and we only have 6 values, so we proceed with caution. But we keep moving on because it's fun. Step 4, do the calculation. X bar minus mu, standard deviation number. That gives us negative 2.14 with a differential. Degrees of freedom of 5, 6 minus 1. Now we draw our chart. Okay, negative 2.14 right there and shade. Now remember, this is using the non-rounded. I'm going to put this in the calculator. So in this one, I'm going to do my second vars. 6. Negative 999 stays. This becomes negative 2.14. And my degrees of freedom is 5. Okay. Now I'm going to get a slightly different, was pretty darn close, 0.427. So pretty close. And then 6. Since my p-value is less than 0.05, we reject the hoe. We do have convincing evidence that the true mean is less than 80. So Spezio is probably right. And that's it.